All right, so lesson number 7 is on inverse relations. So we're going to skip over lesson 6 for now, transformations, but we are going to do a little bit with transformations today. So hopefully you kind of remember it. So an inverse function is a function that results from interchanging the input x and the output y values of a function. So you're just switching the x values and the y values. So it says the inverse of f of x is denoted by f inverse of x, f to the negative 1 of x. Okay, so if you notice from the graph, one of them, the black line on mine, is f of x, and the blue line is f inverse of x. Okay, so every point that I have on f of x, like 1, 10, I don't have the same point on f inverse. I have the opposite. It flips over. It becomes 10, 1. Okay? So if I have negative 3, 2, that means I have 2, negative 3. And what happens then is it ends up being a reflection over the line y equals x. So that's why the curve is perfectly symmetric over that line. Okay? So it says assume f is a one-to-one function. So a one-to-one function is just a function that has a unique inverse. Let f of 0 equal negative 2, f of 1 is 7, f of 2 is 5. Find f inverse of 7, f inverse of 5, and f inverse of 2. So for the f function, what this means is I have the point 0, negative 2, right? F of 0 is equal to negative 2. And I have the point 1, 7, and I have the point 2, 5. So what point should I have for f inverse? Instead of having 0, negative 2, I should have what? Negative 2, 0, exactly. So instead of 1, 7, I have 7, 1, and instead of 2, 5, I have 5, 2. So when I ask these questions and I say, what is f inverse of 7? F inverse of 7 is going to be 1, right? Because I have the point 7, 1 for the inverse. And f inverse of 5 ends up being 2, and f inverse of negative 2 is 0. Those are my answers. So you're just switching the x and y values. So we just said let f be a function. If a, b is a point on the graph of f, then b, a is a graph on its inverse. The graph of the inverse of f is a reflection of the graph across the line y equals x. And a one-to-one function is a function in which each y value corresponds to exactly one x value. The inverse of a one-to-one function is also a function. So if something's one-to-one, it's going to pass the horizontal line test, which is here. Nope, horizontal. So it says if a horizontal line crosses the graph of a function f at more than one point, then the inverse is not a function. So think about that. If I'm switching all of my x and y values, basically if I have a graph that looks like y equals x squared, and I switch all of my x and y values, it ends up going over here. Do you see how that's kind of a reflection over the line y equals x? Okay, that is not a function. A parabola on its side is not a function. It fails that vertical line test, right? So in order for something to be one-to-one, in order for it to have an inverse that is a function, it needs to pass the horizontal line test. Okay, so we talk about the horizontal line test because when we flip it, we talk about the vertical line test. Do you see what I'm saying, how they're related? All right, so are the following functions one-to-one? So if I have f of x equals x squared, I just said that this is not one-to-one. It fails that horizontal line test because it touches 2 points at once. Okay, you can think about any of those points. Like you have 2, 4, and you also have negative 2, 4. Those would be the same, they would be on the same horizontal line, right? So it can't be a function because a function, if I have a certain, let's see, x value, I only have one y value that goes with it. So basically it's saying on its inverse, we would have 4, 2, but we'd also have 4, negative 2. That would not work for a function. Does that make sense? This one's a no. It is not one-to-one. We write one-to-one as 1-1. All right, g of x equals 1/2 x cubed. Well, an x cubed function looks like this. Does that pass the horizontal line test? Yes, it does. So yes, 1-to-1. All right, and then 2x minus 5, that starts out at a y-intercept of negative 5, and now I have a slope of 2. So yes, this is also 1-to-1. Okay, so what's going to be important about the one-to-one thing is if we're finding an inverse of something that's not one-to-one, we have to restrict the domain. Okay, so we talked about that a little bit last year. Some of you guys didn't like it. We're going to revisit, and hopefully it makes more sense this year. Okay, so composition of inverse functions. So sometimes maybe on the test I say, are these two functions inverses of each other? So there's lots of different ways that you could see if they are inverses of each other. So one thing you could do is you could find f of f inverse of x, or f of g of x in this case, and see if you just get x out. If that happens, then it is an inverse. You could also do it in the other direction, g of f of x, you would also get x out. So it says, show that f of x equals 2x minus 5 and g of x equals x plus 5 over 2 are inverses of each other. So if I find f of g of x, it looks a little weird at first. You have 2 times whatever our new x value is, right, the g of x, minus 5. So we're plugging in the g function into the f function. We're replacing the x with x plus 5 over 2. All right, so it looks scary, but it's not, because what happens are the 2's cancel. So we get x plus 5 minus 5, which is just x. If you get just plain x out, that means that they are inverses of each other. So yes, inverses. And it doesn't matter which way you do it. If you do g of f of x, you will also get x. So if I take my f of x function and replace my x value with 2x minus 5, so I get 2x minus 5 plus 5 all over 2. See how I get 2x over 2, which is also x. So we're done. So yes, they're inverses. So that's one way you can tell if things are inverses. If you do g of f of x or f of g of x and you get x out. All right, the other way is you could actually find the inverse. So we did this last year. It's a pretty easy process. It's not bad. So all you're going to do is you're just going to switch your x and y values and solve for the new y. So I have all the steps written there. So instead of f of x, we know that f of x is just y. So I have y equals 2x plus 3 all over 4. And I'm going to replace my x and y with each other. So I'm going to switch them around. So I'm going to have x equals 2y plus 3 all over 4. And we do this because to find an inverse, we switch all of the x and y values. So if I had a point 2, 5, I switch it to 5, 2. So I'm just doing that. I'm switching all of those. And I solve for the new y. So I'm going to multiply the 4 over and get 4x equals 2y plus 3. I subtract the 3 over. I divide by 2. So I get 4x minus 3 over 2 equals f inverse of x. So that's our answer. Now just be aware that maybe your friends, as you're doing these problems and you're checking with your friends or checking in the back of the book, right? Maybe there's a different answer. That could happen. Maybe it's just written in another form. So notice, like, you could bring the 2 into both pieces. You could also write this as 2x minus 3 over 2. That would be fine as well. Okay? So you could have different answers. All right, so next one. So we have f of x equals the cube root of 1 minus 4x. So we have y equals the cube root of 1 minus 4x. We switch our x and y. Yeah, you with me? We solve for the new y. So we're going to cube both sides. We solve for y. We subtract the 1 over. We divide by negative 4. So we get f inverse of x equals x cubed minus 1 over negative 4. Now, if you're taking like a standardized test, like the SAT, PSAT is coming up, right, and they ask for the inverse, they probably wouldn't put your multiple choice question like this, right? It wouldn't look like this. What would they probably do instead of having a negative 4 on the bottom? Yeah, make it positive and then make the numerator the opposite. So you would have had like negative x cubed plus 1 all over positive 4. But I think they probably would have written 1 minus x cubed all over 4. Because it's just cleaner. I like to write 1 minus the x cubed. So that's probably what it would look like. Again, you could also have 1/4 minus 1/4 x cubed, something like that. You could have lots of different versions of this answer. Makes grading these oh so fun. Grading, oh, killing me. Everybody's always like, then just assign less homework. I'm like, no, then I don't know. I want you guys to learn. So. All right, so continue to try these. So f of x equals 2/3 times 7 minus x. So let's switch our x and y. So the y is the f of x, so I'm going to have x equals 2/3 times 7 minus y. So you could do a couple different things. You could multiply the 2/3 in, right? Or you can get rid of the 2/3 now. What could I do to get rid of the 2/3? Multiply by 3 over 2, right? So I could multiply both sides by 3 over 2. So I'm going to have 3 over 2x equals 7 minus y. So I'm going to have 3 over 2x minus 7 equals negative y. And then I'm going to multiply everything by a negative 1. So I'm going to have negative 3 over 2x plus 7 equals y. So that's our F inverse. So F inverse of x equals, so maybe 7 minus 3 over 2x. Probably the easiest way to write it. Okay. All right, so those are all pretty straightforward. I think you guys can do those. A lot of them on your homework are like that. I think you have like 7 problems or something on your homework. It's not much. These are the ones that are hard. So when you have g of x equals 5x minus 7 over 3x plus 5. Okay, when I switch my x and y, the thing that's different about this is now I have I have 2 y's, right? 2 y values. So it's kind of hard to solve for y. You can't have y equals and then have something with x's and y's on the other side, right? If you're trying to get y equals, you need only one thing that says y equals. Nothing else can have a y in it, okay? So what we're going to do to solve this one is we're going to multiply the denominator over, and we're going to multiply the x in. All right, and then we're going to do a little trick. Does anyone remember the little trick? Catherine, do you know it? No? Kyle, do you know it? No? Julia? Ah, close. Don't divide by x. Close. You're going to divide, well, you kind of want the y's to be on the same side, though. So get y's on one side. And everything else is going to go on the other side. Oh, on one side. On one side. So we're going to have the 3xy, and we're going to have minus 5y, and then we're going to have negative 5x minus 7. Now we can pull out the y, because now we have a y in common. So we're going to factor the y to the front. So I have 3x minus 5. Yeah, now you guys are all like, oh, I totally remember this. So we get y equals negative 5x minus 7 over 3x minus 5. Okay, but that's way too many negatives. A standardized test would never have all these negatives. So what do you think the most simplified form is? So divide by negative 1 on the top and bottom. So 5x plus 7 over, how do you think they'd write the denominator? It'd be negative 3x plus 5, which is the same as 5 minus 3x. Just flip it around. Does that make sense? Maybe. So I'll accept either form, like I'll accept the one that's directly above this, or I'll accept that one. It doesn't matter. All right, so that's kind of about as hard as like finding the inverses gets. But there is one last thing that we need to discuss. So this is when things are not one-to-one. Okay, so it says, question, when you graph to each of these, the new function looks like the previous function's reflection over the y equals x. So you can play around on your graphing calculator, you can graph both of those things, and you would have curves that are totally like a reflection over, ooh, that was pretty good. A reflection over the line y equals x, right? But sometimes we have a problem. So I'm going to show you what the problem is with this one. So if I have y equals x squared minus 1, if I graph that, it's like y equals x squared, only it's been shifted down 1. So I could do a t-table. If I plug in 1, I get 0. If I plug in negative 1, I get 0. It's a parabola that goes through 0, negative 1, 1, 0, and negative 1, 0. Okay, this is not one-to-one. Okay, so what it means is that it's not going to have a unique function that is its inverse. So let's see what happens when we solve it. So if I switch my x and my y, and I solve for the new y, I get x plus 1 equals y squared. I now take the square root, and what do we write when we take a square root? Plus or minus, that's correct. So what we actually have is positive square root of x plus 1, but also negative square root of x plus 1. We get two functions. So what they really look like is here and here. It's not drawn very well, but you get it. So it looks like that, which is a reflection over the line y equals x. Right? It's a reflection, but it's not a function. Right? We need for it to be just a single function. That's why this whole section is called inverse functions, right? So we have a problem. So what we should have said on the original is that we should have said on some domain. So let's say I say on 0 to infinity for its domain. If I have 0 to infinity for its domain, what ends up happening is it's only this part of the parabola. That's all I have. I don't have anything from 0 to negative infinity. All the negative numbers are out. That's the only part that would be graphed. Is that one-to-one? Yeah. So basically, when you restrict the domain, you want to pick one side of the domain. It doesn't matter which side. So in this case, I picked a side. I picked the right side. Yeah.
When you like reverse the, or when you plug it over the y-axis,
Oh yeah, it should be back a little bit, shouldn't it? It should be down here. Yeah, I'll give you a point for that. So it should be back here. Thank you. I got in a hurry. All right, so Emerson gets the point. All right, so it's a Monday. Can you tell it's a Monday? I would give more bonus points on Mondays than I do. Yeah, there's lots of names on the board. All right, so anyway, so we're going to restrict the domain. So we're restricting the domain to 0 to infinity. When we do that, what is our range? So what's the smallest y value we have then? -1, right, to infinity. So that means on our inverse function, we want to pick the one, so we have a choice between plus or minus, that's going to give us those opposite numbers. It's going to give us our original domain, which is 0 to infinity. That's going to be our new range. So we want our range to be 0 to infinity, and we want our domain to be -1 to infinity. So we make a decision. We decide if it's going to be plus or if it's going to be minus. So as I'm plugging things in, if I'm plugging in -1, I'm plugging in 2, I'm plugging in 3, I want the one that's going to give me 0 to infinity out. Which one gives me positive numbers out? The one with the plus, right? Does that make sense? So I can't have the negative, I have to have the positive. So that's our inverse function. So it's kind of weird. So if I had told you the domain was -infinity to 0, then it would be the other one. So we'll do a couple like that. So I have y equals the square root of x minus 4 minus 5. Okay, so let's find the inverse first. So if I'm finding the inverse, I switch my x and y. I'm going to add the 5 over. I'm going to square both sides. So I get x plus 5, quantity squared, equals y minus 4. So I'm going to add the 4 over, and I get y. So that means my inverse is y equals, let me write the y equals over here, is y equals x plus 5 squared all over 4. Okay, that's a parabola. Is that one-to-one? Is not one-to-one. Parabolas are not one-to-one. Okay, it is not one-to-one. So its inverse has something strange about it. Okay, so we need to talk about the domain and the range for the original. Okay, if you sketch out the original, it could help you. You could use your calculator too and graph it. This is why I said we would have a little bit of transformations in this section. So do you guys know what the square root of x looks like? The square root of x looks like that. Okay, that's the function that it looks like. Okay, so this one's different because I have x minus 4. So what happens when underneath that square root I have x minus 4 instead? What direction does it shift? No? Nope. It goes to the right. Remember, when it's inside with the x, it does the opposite of what you think. So you'll remember this as we go back and do the transformation. So we go to the right 4. All right. What about the minus 5 on the end? There's a minus 4 on the inside. So we're looking at the inverse, or the original, this one. All right, so now I go down 5, so I'm down here. So my square root function looks like that. So the original is there. Okay, that's going to help us identify the domain and range of the original. So what's the domain? The domain is all the x values I have. What's the first x value I get to? 4. So it's going to be 4 to infinity. What's the range? -5, oops, bracket, -5 to infinity. So that means our new one this one, we want it to have a range of 4 to infinity and a domain of 4 to, or sorry, not 4 to infinity, negative 5 to infinity. We want them to switch. Because remember, domain is all the x values, range is all the y values. So when we switch all of the x's and y's, our domains and ranges switch. Okay, does that make sense? All right, so all we need is we just need to write this as well. So that's what we need. So we need the inverse function and we need its new domain. We need to have both of those listed. So what happens is it's basically a parabola that's been shifted left 5 up 4, but it's only from negative 5 to the right. It's right there. Do you see how that's going to be the thing that's going to be a reflection? The other side of the parabola would not be a reflection. All right, so let's try this other one. We'll try it in a different order maybe. So let's graph this first one. So if I have a square root function, it's going to go, since I have x plus 1, I'm going to go left 1 and up 3. And it's going to look like that. Okay, what is the domain and range of the original? Domain is bracket, where does it start? Negative 1, and it goes to infinity. And then range, where does it start? 3 to infinity. So we're talking about the x's and the y's. Yeah. So now we want to find the inverse. When we find the inverse, I have to list its new domain. Because it's going to be a parabola, but I'm only going to have part of the parabola. I'm not going to have the entire parabola. So I'm going to do x equals 2 square root of y plus 1 plus 3. I'm going to subtract the 3 over, and I'm going to divide by 2. And then I'm going to square both sides. So I get x minus 3 all over 2 squared. So if I square the top and then square the bottom, I'm going to have, instead of having 2 on the bottom, I'm going to have 4. So I'm going to square the bottom as well. All right, and then it equals y plus 1, so I subtract the 1 over. That's going to equal my inverse. Okay, so think to yourself, this is a parabola. A parabola doesn't have a unique inverse because it's not 1-to-1. So you need to say, okay, well, I want only the one side of the parabola. So basically, I want it to look like this, right? To be an inverse of that, to be a reflection over the line. So I need to pick the domain. So its domain, and that's all you have to write. You don't have to write the range. Its domain needs to be the old range. So it needs to be bracket 3 to infinity. That's your answer. Okay, that is the thing that's the inverse of that square root function. You have to have the domain. All right, so this one's saying f of x is equal to x squared plus 4 for x is less than or equal to 0. So let's think about what the graph looks like. X squared plus 4. I go up 1, 2, 3, 4. So I have a parabola. However, it's saying that I have a restricted domain already. So this one has the restricted domain. What's its domain? Everything less than or equal to 0. So which side of that parabola can I keep? The negative side, the left side. Do you guys see that? That is not a one-to-one function the way I've drawn it, because it passes more than 1 point on the horizontal line test. It touches more than 1 point, right? So that's why I've included the x is less than or equal to 0. So that means we get rid of the right side. So it's open like that. So let's list the domain and range for the original. That can be helpful. So if I list the domain and the range, the domain we said was everything that was less than 0. So it's negative infinity to 0, bracket. Range, what was the first y value we hit? Uh-huh. And that is actually filled in. So it's bracket 4 to infinity. Exactly. So now when I find the inverse, so I do x equals y squared plus 4. I subtract the 4. I take the square root. Whenever I take a square root, plus or minus. So I get y equals plus or minus the square root of x minus 4. This is two functions. So we have to choose between the plus or the minus. So we want our domain to be the old range. We want it to be 4 to infinity. This time our domain is definitely 4 to infinity. Those are the only things I can plug in for the square root. This is when you actually need to look at the range. So it's when you start out with something x squared. So our range has to be negative infinity to 0. So I want to get output. I want to plug something in and get negative values out. So which sign do I need then? The negative. Does that make sense? So you choose between these two. We're choosing the negative. So cross out the other one. That is our function. Because I knew that my range had to be negative infinity to 0. I needed to be able to plug in certain values and get a negative number out. So the only way I can do that is with the negative output. So you can think about different values on the graph. If you want to do a little t-table, you can think about, oh, I have the point 0, 4. Oh, I have a point, on this one. So I have 0, 4. I have negative 1, 5. Well, that means on the other one, you want to get 4, 0 and 5, 1. So what happens, or sorry, 5, negative 1. So what happens when you plug in 5? You want negative 1 out. So that means you need the negative. So you could do it that way too if that's more comfortable. Yeah, so if you have the negative square root of x minus 4, it would look like, this. So it would start out with going right 4, and then it would flip over the x-axis, so it would be down there. So it would be 1, 2, 3, 4. It'd be like that, which does look like a reflection. So you could check by that too. All right, so let me tell you what your homework is.